So my name is Kostis. I'm a developer advocate working at Codefresh. Codefresh is an enterprise platform for Argo. I'm also a maintainer for Argo rollouts, and I'm actually contributing to documentation, so not that features. So if you wanted to contribute to Argo CD, you don't want to learn Golang, there are ways to do it. Come find me after the talk. I'm also the co-author of the first ever Argo CD / GitOps certification, which is something different than what was announced in the keynote today. And I'm going to say some things about this in the end. So what are we going to talk about today? So you installed Argo CD or Flux. It works, it's stable, and then you start using it. And your job is to approve pull requests. So this is a pull request that somebody else had created it. And your job is to look at it and say if you want to approve it or not. So you look at it and you see, OK, it's changing the number of replicas. Looks good. Maybe it's Black Friday and you want to increase the replicas in production. You approve it, you merge it, and nothing happens. And nothing happens because, let's say you're using customize. You change this file in a customize overlay, but there was another customize overlay downstream that had an override in the replicas field, and your change did absolutely nothing. The same thing can happen with Helm values. So this is the scenario we're talking about. You have a structure of customized overlays. This is your base overlay, and then you have overlays for staging and production, and they have downstream overlays for different regions. Or you can imagine the same example with Helm values, and they have hierarchies. So by the time you look at a pull request and you need to approve it, your context is only the overlay or the Helm value for the change, which is not enough. This is not what you want. Ideally, you would like to have the full context, know the whole hierarchy, and know the actual change, because then you can make an informed decision and say, yes, this is the change that I want to approve or not. So this is a problem we're going to talk about today, and I'm going to show 4 solutions, 3 wrong ones, and the correct one. Especially for Helm users, you also have an extra problem that Helm is using templates. So if your Helm templates are super complex, sometimes you need to approve a change like this. And one of my favorite things is to mentally run Helm in my mind and understand what is going to change. Said no one ever. So it's also the same problem or a similar problem that ideally you would like to see the full manifest and not the Helm template, because this is what will go to Argo CD. So let's see the choices, what you can do. The first choice, which is obvious, if you have seen Argo CD, has the capability to show you a diff. So if there is an out-of-sync resource, either something has changed in Git or in the cluster, Argo CD can mark it for you, and it tells you exactly what is the resource that changed, and then you can click on it, drill down, and see what is the change. And in this case, you are looking at final manifests. So all the overlays are not important anymore. The Helm templates are rendered. You are looking at the final change. This is what you want, and it looks good. But it also has some issues. First of all, in order for this to work, you need to disable auto-sync and self-heal. And you shouldn't do this, because then you are not truly following GitOps. If you want to follow GitOps, both these options should be enabled. So by the time you change something, it's applied right away, and you don't see any diff. The other problem is that this happens very late in the process. Like Argo CD is looking at the final manifest that is committed and pushed to the branch that is defined by the application. So this is super late. If you disagree with that change, it's not very difficult to do anything. But on the other hand, it's built into Argo CD, and there is nothing to set up or create there. So can you use this? Yes, I think you can do it. I would only do it in production environments where many people don't want to have auto-sync enabled. They want an actual human to be able to approve the pull request. And then I would use it only for sanity checking. So I have already done my, let's say, official checks and my official approvals of the pull request, and I'm just having a last set of eyes to do it. But only for last-minute, let's say, verifications. The other thing you can do, and this is also another good question, how many people have used the Diff command in the Argo CD CLI? How many have How many people have used the minus local argument? There, okay, some people. So there is a similar thing to do, a similar capability with the Argo CD CLI that allows you to diff the application, like what is in the cluster against local manifest. And again, it has full support for everything that Argo CD supports. So if you're using Helm, it runs the templates. If you're using Customize, it applies the customizations. So this is how it looks. I run it here, and I see some changes. If you ask me, this is one of the features of Argo CD that is not publicized very well. But it's really important because you can diff against files that are in your laptop, like they're not committed anywhere, they're not on a Git repo. And you can imagine that if we have this, let's say, building block, the next obvious thing to do is to have your CI system run this as a command, as a part of the CI process, and then attach the result in the pull request. So by the time you look at the pull request, you not only have what your diff provider is giving you, but you also have the capabilities of this Argo diff command. So it works. It solves the original problem. You have the full context of everything. Again, it's built into Argo CD. There's nothing that you need to do there. But it has some issues in regards to security and how it needs access to the Argo CD cluster. In order for this comparison to work, the CLI needs access to the Kubernetes cluster and the Argo CD instance. So you need to allow your CI system to have access to your Argo CD cluster, and maybe you don't want to do this, or maybe you are not even allowed to do this. Maybe let's say your CI server is in the USA, and your Argo CD instance that you're deploying is in China, and maybe it's not even possible to do this. So your security people might not be very happy about this, and you also need to do some networking setup. So my recommendation, it's great if you're experimenting locally. If you want to try something quickly on your laptop and you create a manifest and you don't want to commit it somewhere at this point in time, you run the diff and you see, okay, yes, this is what I need. But I wouldn't use it for any production installs or anything else. So here I have an intermission for Terraform, because I think this is really interesting. This problem that we're talking about is not really new. Terraform people had the exact same issue. Normally, you don't want to run Terraform apply. Terraform also has a plan command where it tells you what it's going to do with infrastructure. And by default, it prints a nice report where you can see, OK, my change is really what I need. So the obvious thing to do, again, is to take this report and have your CI system run it for you, and then attach that report to the pull request. So by the time you look at a Terraform pull request, not only you have the diff in the Terraform files, but also you see what is actually changing in your infrastructure. And this is a very common scenario. There is actually an open source project called Atlantis that you should look if you're not familiar with this, and does exactly that. It attaches Terraform plans to the pull request. So in a way, it's similar to the Argo CD CLI workflow that we've seen before. But again, there are some issues here. In order for this to run, Atlantis needs the Terraform CLI, the exact same version that you use, access to the Terraform state. And if you're using Terraform, you know what that means and its implications, and access to your cloud provider. Essentially, it needs everything. It has the keys to the kingdom. So yes, it works, but again, your, let's say, security people and networking people might not be very happy about it. And I'm mentioning this because this is something that was already present for Terraform people, and it doesn't mean that we need to do the same thing and the same workflow. Maybe there is a better case a better solution in the case of Argo CD. Pre-rendering the manifests, that's another solution, and I'm happy that we have a guy from Intuit here because I love this. So another approach is essentially you pre-render the manifests and save them to an external Git repository. And this is a third Git repository. Remember, we said that one of the good Argo CD practices is to have a Git repository for the source code and a Git repository for the manifest. Now we have a third Git repository that has manifests. And Argo CD is looking at that second Git repository. Argo CD is only looking at final rendered manifests. It doesn't know about anything else. So the way it works is that you as a developer work on one Git repository that has your, let's say, Helm templates or your customized files, and then you need an automated process that renders the manifest when you do a change and commits them to the second Git repository. And here I'm mentioning a second Git repository, but some people might prefer a different branch on the Git repository or a different folder. The end result is exactly the same. So this is how it works. One Git repository is the one that humans interact, which is at the top, and it has my, let's say, original files. And then the second Git repository is at the bottom, which is the one that Argo CD is looking at, and it has only final rendered manifest. And you need to set up an automated way that takes the source manifests, and then renders them whenever you do any change. Now, this might look simple in theory, but in practice, it needs also some other stuff. I, as a human, should only interact with the first Git repo, so I'm going to create a pull request there. But the diff, I want to see, if you remember the previous slide, is on the final render manifest. So I also need a second pull request on the other Git repository. So how do you create this? Manually, or maybe you have your CI system does this for you. And then once I approve my pull request, if I approve the pull request on the first Git repo, I also need the pull request on the other Git repo to be approved, or if I reject it. So I'm just saying this, that this needs some setup, and you need to account of all the scenarios and workflows that come with this approach. But the end result is great. So this is the same example that I've shown in the beginning with Helm. Here I have a diff, and because I'm doing it on the second Git repository that has the final rendered manifests, I actually see a manifest and not a Helm template. So as a user, this is very easy for me to say, OK, this is what I need, and I don't need to run Helm template in my mind. So the problem is solved with this approach. So you could use it. There are some companies that are using it, and Intuit is one of them, and there are others. It solves the original problem. You're looking at a full context. Especially if you use Helm, it's super useful, but everything else is a disadvantage. You need to set up this copying / rendering process. There are more moving parts right now in your deployment process. Your CI system also now becomes a point of failure, because if this rendering process doesn't run, you cannot deploy. So if your CI system is down, even if Argo CD is up, there's nothing that you can do. And also, if you're working in a big company, you need to pay attention to onboarding people and to explain what is the process, because a very common mistake is that people will commit to the wrong repository. So maybe I'm starting a new position in this company, and I go to the Argo CD instance, I look at the applications, I look at the repositories that are used, and I find the second Git repository, the one that has the final render manifest. And then I make a change, and I don't understand that this is not the way I should do changes. So you need to pay some attention there and place some guardrails on what people can do and they cannot do. And if you're using a separate Git repository, now you have the double number of Git repositories. You have essentially 3 for each application: the source code, the final rendered manifest, and the Helm charts. So it works, but if you ask me, it's complicated, then you need to have, let's say, a well-disciplined team in order to make it work. So if you're already using it, that's fine, but I think there are better solutions for this. So yeah, that's the result. You can use it, but make sure that you know what you're doing, and you can explain to people what they are doing and what they should not be doing. So we have seen the 3, let's say, approaches that I don't like, and this is the one that I personally recommend, which is rendering the manifests on the fly. So here, remember I said that we should not look at what Terraform is doing and reevaluate our stance according to what Kubernetes and Argo CD is doing. One of the problems that we had with Argo CD CLI is that we needed to ask the cluster about the current state and then perform a diff. But if we are following GitOps, we already know what is in the cluster. It's the same thing as in the Git repo. So we can cheat here and do a comparison just between Git. So say, see what is the pull request that is coming, and this is the proposed change, and assume that what is in the cluster is in the main branch or the master branch. So we perform a diff between 2 Git states, 2 Git different branches, and not the cluster. So this is how it works. We still have a single Git repository that you can see at the bottom. I, as a developer, as a DevOps person, still interact with a single Git repository. And whenever I do a change, an automated process just renders the manifest on the fly by doing this Git diff between the pull request and the main branch, and then attaches the result as a comment. And Argo CD is looking at the exact same Git repository. So it's a single Git repo. The CI system does something, but is not a single point of failure anymore, and I get a nice diff. And I integrate that to my pull request process. I'm also going to show an example, but in any CI system, it's super easy to get the files of the pull request, the files that are in the main branch or the target of that pull request, and then perform a diff and attach this to the issue. So this is a live example. I'm looking at a pull request, and this is a comment on the pull request. And unlike the first example I've shown, this comment has final rendered manifest, and I can see again exactly what has changed. It's not Helm templates. It's not customized files. So as an end user, I get what I want, and the problem is solved. So is it perfect? No, it's not perfect, but in my opinion, it has many advantages. First of all, we're working only with Git. We don't need access to Argo CD anymore or the Kubernetes cluster. We don't care about the topologies. There are no problems with networking. We still use like the support that Argo CD is using for Helm and Customize. There is no confusion over multiple Git repositories, and it also works for Flux. So all the previous solutions, maybe they were Argo CD specific. This is not, so even if you are using Flux, you can do the exact same thing and preview what is going to change. So if you move from a company that has Argo CD and go to a company that has Flux, you can do it. There are some disadvantages. First of all, you need to set up this. Again, you need to set up this rendering plus commenting process. But as I said, your CI system is not now a single point of failure. So if your CI system is down, you can still deploy, but you don't get access to this nice diff. And specifically with Helm, you might miss our corner cases on what you see with this diff with what actually goes into the cluster. So maybe in some cases, it's misleading, but I think the advantages outperform the disadvantages. So my recommendation is that this is a very simple process. You should use it. It's scalable. And it can be used for both production and testing environments. And as a bonus, I also want to mention another scenario. So far we have been talking about looking at the changes and understanding what will change when you merge a pull request. But another important scenario is understanding what will not change, so the opposite. So in a previous presentation, I was talking about organizing your GitOps repositories and how to model your applications in a Git repo. And there were also some other presentations talking about this very same topic. I'm not going to go into this right now, but I'm going to talk about a very specific scenario. So this is a folder hierarchy. The purple boxes are folders, and the blue boxes are, let's say, customized overlays or Helm values, whatever you prefer. So on day one, somebody comes to you and says, OK, we need to have this change in staging. So you make a change in the customized overlay that is in staging. You approve it, you merge it, you apply it, and it works. 1 week later, they come to you and they say, OK, we need this same change in production. So you go to the production overlay, you do the change, you apply it, you merge it, and it works. And then you look at this and you say, OK, well, I have this duplication. If you're using Customize, the obvious thing to say is, OK, I'm going to remove this change from the individual overlays. And since it's common, I will add it to the base overlay one level above. Or if you're using Helm values, maybe you want to move that value one level above. So that final step is mentioned in that article about GitOps repositories. And several people said, oh, this is too complex. I'm not going to do this refactoring because I don't know what will change. I don't want to touch too many environments at the same time. This is super risky, and so on and so on. And when I look at the comments of those people, I realized that they didn't have this presentation in mind. So this is the plain diff that the Git provider will show to you. And you can see the changes are not really important, but you can see a change is removed from 2 environments, and then you add another change in the base overlay. So you look at this change and you say, oh, this is touching 3 environments. It's super risky. I'm not going to do anything. Forget about it. But if you adopt the approach I'm talking about creating a smart diff, this is what you would see. So this is my own smart diff that compares the main branch against the pull request. I have 3 environments, and you can see it's absolutely empty. So I can look at this pull request with my own smart diff, okay? Smart diff, plain diff, smart diff, plain diff, smart diff, and say, okay, I can merge this with 100% certainty that nothing will change. I will merge this, and Argo CD will do absolutely nothing, even though technically I touched 3 environments. So I did a refactoring, and I know that my refactoring is correct. There is no risk. And if you have this information, of course, you can do as many refactorings as you want without any fear. So I'm saying this is, again, super important because now, with this system, I know what will not change, not just the changes. So think about this scenario as well. Now, many people ask, how do I get this diff? I have a URL at the bottom, and there is an example with GitHub Actions, but you can do the exact same thing with Circle CI, Codefresh, Jenkins, whatever CI system you use. It's not that complex. So we have seen 5 solutions about previewing the changes that will appear in your application. First, we have the naive Git diff that doesn't have any context, so don't use it. We have the UI diff that Argo CD is offering. This is a great building choice, but it's far too late in the process, so I wouldn't recommend it. We have the CLI local diff, which is great for experimentation, but if you want to put in a production instance, you need to give access to your Argo CD instance from your CI system, which is something that maybe you don't want to do. You can pre-render manifests and place them on a second Git repo. This is a solution that it works, but it's super complex if you ask me, and you need to explain to people what is happening behind the scenes and how they should use it. And my personal recommendation, you render the manifests on the fly, and you attach them as a comment on the pull request. So some resources. The first one is a link to the blog post that has this presentation plus more details. The second one is the Atlantis project, which if you're a Terraform user, you should look at if you haven't seen it. And then the last one is the certification, which is a training, not just a certification, where you get an Argo CD instance on your browser, and you can work through various scenarios. And it also includes the thing that I talked about with multiple environments and promotions between environments. So in this case, there is a scenario where in your browser you get 3 real Kubernetes clusters plus an Argo CD instance that controls these Kubernetes clusters, and you can do promotions. And there is a cost to this certification because of this cloud provider, but with this code you get 100% off this price.
Are there unlimited codes, Kostis?
There are maybe less codes than people in the room. So that's it. We have 5 minutes for questions.
Hey, I really like that, Kostis. Looks great. Just curious, it looks like the CI is rendering the diffs. Are there any edge cases where that might be problematic? Like, for example, Flux can do a help lookup. In Argo, you have the values potentially in the application, and then plugins, which can decorate based on the cluster.
So the last thing might be
gotcha.
corner
Thank
cases
you.
is exactly that. There is another
Yeah, I
guy.
think I was about to ask the same thing in terms of how you account for configuration on the application resource for customize or help. Sorry, okay. I think I was asking the same question in terms of, how do you account for configuration on the application resource with regards to Helm or customize in that way? And the other side of it is then version differences as well between what you're running in CI versus what's actually running on the Argo CD server.
So this problem can be solved, let's say, easily. You can query Argo CD and ask what kind of versions it uses. One question that you didn't ask is what you do with application sets. So if I'm using, let's say, application sets, ideally, I would also like to preview what applications are created by the application set. So it's not that simple, but it's a good, let's say, starting point of getting into this mentality. I will use the GitOps principles and assume that I have something in Git. And it's a trade-off. Like if you have something that works 90% of the cases, maybe this is enough for you, and for 10% you do something else rather than doing something else for 100% of the cases and making your life difficult. But if this would be let's say, a real setup, essentially you would need to replicate everything that Argo CD does dynamically for an application, including application sets and Helmer Customize or any plugin that you might have in Argo CD. So all these might miss some corner cases at the end.
Hi. I just wanted, I'm not sure if this is also a corner case where, so right now for this method, you're assuming that it doesn't ever need to connect to the Kubernetes cluster, doesn't ever need to connect to the Argo CD API. And so if there was a resource that got edited by something else, basically I think what my developers would say well, I don't have 100% confidence that this diff is going to show me the real, what's actually going to happen. If when they compare it to Terraform Plan that they were used to, that actually connected to the Amazon API and that gave me real time, this is what's going to actually happen. So I'm trying to understand here, what sort of confidence can I give to my developers that this method will give you a reliable way to say hey, what you're about to change the Helm chart is going to be there.
I think that the people that are supposed to approve a Helm request, they should have the knowledge in the first place of the corner cases, and they should be able to say, okay, for this change, the smart diff I'm looking is really smart, or what I'm looking is not that smart. So I won't say that this is something you offer to developers. I'm going to say this is something you offer to the people that approve pull requests for Kubernetes manifests. If in your case they are developers and you assume that they know what they're doing, that's fine. But if in your case it's only a very small subset of people and they are the experts on the Kubernetes manifest, they should also know what they're doing.
Thank you.
Another one?
There's no API in the Argo API to render the output where you could pass it a call and say, hey, I want you to render this for me.
As far as I know, no.
Okay, thank you.
There is one, and you can pass it with vision, so you can pass it your PR range, and it'll generate the custom.
Because the idea I was thinking is you could just get Argo to render this for some arbitrary PR, right?
Yeah, you still have to have the API access, which may be more broad than you want to give.
Right. Okay, thank you.
So for people that don't know him, we are lucky enough that we have Michael, the Argo CD guy, here. So if you have any advanced Argo CD questions, you can ask him. Okay, any more? Okay, thank you very much.